Bismillahirrahmanirrahim. Welcome to topic 4.2 multi-core programming. Before we can discuss about the multi-core programming challenge, we should be able to distinguish between parallelism and concurrency concept. In section 1, as has been explained in section 1.32, the traditional approach for operating system is a single CPU. Then it evolved into multiple CPU. It still carry one thread per process. Later, we have a multi-core system, which multiple core is placed on a single processor chip. This is our focus on chapter 4. Right, so now we have multiple process with multiple core. Right, this one we will discuss on chapter 5. For multiple core, multi-threaded programming provides a mechanism for more efficient use of this multiple computing core, and it improves concurrency. So what is concurrency? On a single core system, concurrency means the execution of a thread will be interleaved or executed alternately over time. Because each thread, the processing core is capable of executing only one thread at a time. On a multi-core system, concurrency, however, means some threads can execute in parallel. Because the system can assign a separate thread on each core. Right. So now we can see the difference between concurrency versus parallelism. We discussed back about the multi-core programming challenge. There are 5 areas. There are 5 area of challenge that need to face by a multi-core system. The first challenge is dividing activities. We need to find areas in an application that can be divided into separate and concurrent tasks. The second challenge is balancing. We must ensure that the tasks perform equal work of equal value, right? So the third challenge is data splitting, where we need to dividing the data between the different threads. The data access and manipulated by the task must be divided to run on separate cores. The fourth challenge is related with the previous challenge, data splitting. For data dependency, we need to the data access by the task must be examined for dependency. So if there is a data dependency, the execution of the task must be synchronized. The final challenge is testing and debugging. So we need to remember it is more difficult for testing and debugging in multi-core programming compared to single-threaded application, because many different execution paths are possible in multi-core programming. Okay. So that is the 5 challenges need to face by the programmer. Okay, now we look at the final subtopic of this topic, which is the type of parallelism. Okay, we have two types of parallelism, data and task parallelism. Okay, for data parallelism, the focus is to distribute subset of the same data across multiple core, and they need to perform the same operation on each core. Okay, alright. The keyword here, the same data and the same operation on each core. Okay. So for example, okay, we want to sum the contents of an array of size n. Okay. So if we use a single core, okay, one thread will sum the elements start from 0 until the element n minus 1. Okay, while on a dual core, so for example, we use dual core. Okay, for thread A, which running on core 0, could sum the element 0 until element n divided by 2 minus 1. Okay, whereas on while thread B, running on core 1, could sum the element n divided by 2 until element n minus 1. So the two threads will be running in parallel on separate computing core. Okay. Okay, the second types of parallelism, data parallelism. Okay, the focus of the second types of parallelism, task parallelism. Okay, task parallelism. The focus is not to distribute data, okay, but to distribute tasks across multiple core. Okay, so they might use the same data or different data, okay, but they will perform a unique operation on each core. Okay, so that is the difference between data and task parallelism. Okay, so that's all for topic 4.2. Inshallah, we will continue on next topic. Thank you for watching.